Hello everyone, Mr. Lau over here. So today I'll be presenting tutorial 2. So for the first question, it's actually a rate of change from application of differentiation. So what we have here is an inverted water tank in the shape of a cone. The height of this inverted cone is 2 meters with a base radius of 0.5 meters. So it's also being said that water is flowing into the system at 0.01 meter cube per second. So V in is 0.01. Concurrently, water is leaking out from the vertex at a rate of 1.2 times 10 to the power minus 4 meter cube per second. So as per what we learned in class, first we need to determine a few other variables. In this case, we'll label the H and R for the liquid within the tank. Write down what we are given, which is dV dt. dV dt in this case will be V dot in minus V dot out. The rate of water going in minus the rate of water going out. So this value here will be 0.00988. Next, we write down what we need to find, which in this case is dH dt. We chain it with what we are given and complete the chain with dH dV. So we need the dH dV. So obtain that, we need to find V as a function of H. This case is a simple cone formula, which is 1/3 pi r square h. We see that in this formula, we have both r and h. So we must find a substitution to sub away one of it. Therefore, we consider similar triangles. In this case, let's look at the diagram. We'll consider this triangle and this big one to be the similar triangles. So it will be the small base over the big base and small height over the big height. So with that, we will get R equals to H over 4. So we can sub this into our volume formula and obtain volume purely in terms of H. And we'll attempt to use this to sub it into the equation. Oh, we need to do the derivative first, because what we need is dV dH. So let me just differentiate this. And now we are ready to sub this inside. So dV dt is what we calculated, 0.00988 multiplied by dH dV, which is the reciprocal of whatever that we have differentiated. And this will give us a final expression of 0.00988 over 1 over 16 pi h square. And since the question needs the rate of change of height at the instant when h is 0.5, we sub h as 0.5 into our equation, and this will give us 0.20 meter per second. and this will be the rate at which the height is changing. That's it for question number 1. Next, for question number 2 is a vectors question. For this question, we are given 2 points, A and B. So let me just draw a simple 2-dimensional diagram. Point A and point B. Point A is with vector A and point B is with vector B. Next, we are also being told that M is on AB produce, so it should be somewhere here, whereby this length is 1 and this length is 4, based on the ratio given. So we are supposed to find OM. Since in this case, B is in between OM and OA, so we shall apply the ratio theorem formula with OB as the subject. So OB will be equals to 1 times OA, will cross the ratio, plus 3 times OM, divided by 1 plus 3. 3 because this remaining length is 3 units. So we are going to do a rearrangement. Cross multiply and then make OM the subject. So in this case, OM will be equals to 4OB minus OA over 3. So after this simple manipulation, we can sub in the values of OB and OA respectively. That's it for part 1. For part 2, we are asked to consider cross product to find the ratio of area of A and B to the triangle OAM. So first let us find the area of OAM. So based on cross product application, the formula is half times modulus cross of 2 adjacent sides. So in this case, we will take OA and OM. We are going to sub in the values of OA and OM and attempt to cross multiply them. Oops. So the cross multiplication is done through the distributive law. Next, any vector crossed by itself will be 0. So I'm only left with one of the term. So this is my area of OAM. The next step is to find out the area of A and B. But to find out A and B, we need to find out the vector ON first. So it is given that the vector ON is lying on OB such that ON to NB is 2:3. Therefore, we can straight away write that ON is 2/5 of OB. So with that, we can proceed to find the area of A and B. So again, using the cross product application, is half times the cross of 2 adjacent sides. In this case, we will select AN and AB. We need to resolve AN and AB. AN is AO plus ON. And we will cross this with AB, which is AO plus OB. Then we are going to sub in all the respective values. Again, we are going to multiply them together by using our distributive law. So 3 over 5 b cross b. Next, 3 over 5 b cross a minus a cross b, and finally minus a cross minus a, which is plus a cross a. So bear in mind, the multiplication is as how we do it in secondary school, just a mere expansion. Similarly, vector cross by itself will be 0. We can cancel off these two terms. Next, to combine the rest, because for cross product, the order is important, we can switch the order by adding a negative sign in front. So b cross a change to a cross b by adding a minus in front. And now we can proceed to combine them. The modulus will take away the negative sign and leave us with 3 over 10 a cross b. So now we have the area of both triangles. We can finally take the ratio. The area of a and b over the area of OAM. This will give us a fraction of 9 over 20, which is 9:20. So that's it for question number 2. Next, we will move on to question number 3. Question number 3 is related to the summation sign, part under the chapter of sequence and series. So part 1, we are asked to express a certain fraction in the form of an expression. So what we need to do is to simply combine them. To combine them, we find the common denominator. So with this, we can get 4r minus 2 over r minus 1, r plus 1. Next, for part 2, it said, hence, find the expression to this summation sign. So since the word hence is being used, we have to use the result from part 1. For part 1, it looks as though a partial fraction has been done. So it should hint us to be matter of difference. But before we can use the part 1 expression, we got to make them look the same. Also, we are going to apply a half in front. After that, we can apply the expression. After this is done, we can now expand the summation sign. So I'm going to list down the first 4 terms. So after listing down the first 4 terms, we can clearly see that there's common differences. Next is to determine how many terms should we list at the back. So we can pretend that we are going to stop here, and it shows that we are left with the 3 terms from the last 2 terms. So what we need is at least 2 terms behind. So I'm going to list down the last 2 terms. Next, we shall continue with the cancellation. So similar to what we have just now, we are also going to be left with the first 3 terms and the last 3 terms. So I'll write down all the terms that is remaining and then do a simple simplification. That's it for part 2. For part 3, we are asked to deduce an inequality. For this inequality is quite obvious because it is the same expression as part 2. So I'm going to write down the part 2 result. So this is my part 2 result. It's 5 over 4 minus 1 over 2n minus 3 over 2n plus 1. Since this term is definitely more than 0 and this term is also more than 0, we can expect the whole expression to be less than 5 over 4. That's it. Next, we move on to part 4. Again, for part 4, we are supposed to use the answer in part 2 to find out the expression of this summation sign. So by a visual comparison, we can see that we can easily make use of a substitution to make them look the same. So the substitution will be r equals to r plus 1. And we can clearly see that this substitution will make the expression similar to that of part 2. However, before we can use the result in part 2, we got to alter the lower limit because they aren't the same. So we're going to do a minor compensation. And with that, we can directly use the part 2 relationship minus the second term. And with this, we can simplify to get our final answer. That's it for question number 3. Next, we shall move on to question number 8. Question number 8 is a transformation question related to curve sketching. So what we are given over here is fx, which has undergone a series of transformation a, b, and c. After going through the transformation, we end up with gx. So we are asked to work out the expression of fx, meaning to say we have to reverse the process. So we are going to label the reverse process with the prime. So to make things easier to see, we are going to change the gx back into y, something that we are more familiar with. So since c is a stretch with a scale factor of 2 parallel to the x-axis, c prime will be stretched with a scale factor of half parallel to the x-axis. And this corresponds to a substitution of x is equal to 2x. So I'm going to sub it in, and this will be my resulting expression. Next, b is a translation of 2 units in the positive x-axis, so b prime will be a translation of 2 units in the negative x direction. So this corresponds to a substitution of x equals to x plus 2. So I'm going to sub it in and get my expression. Finally, a is a translation of 3 units in the positive y direction. So a prime will be a translation of 3 units in the negative y direction. So the substitution will be y equals to y plus 3. We'll bring the 3 over, and this will give us our final y expression. Therefore, fx is what we have over here. For the other part, they're asking if 1 over fx, if it undergoes the same transformation, will it be equivalent to 1 over gx? So let's see. If I have 1 over fx and we go through a, which is a substitution of y equals to y minus 3, we'll get this. B, substitution of x equals to x minus 2. And C, substitution of x equals to half x. So this is what happens if we allow 1 over fx undergo ABC. Next, how about 1 over gx? So let's work out the expression of gx first. So gx is a resultant of f undergoing a, b and c. So with the similar substitution, we can get the expression of gx in terms of f. So this is my gx. Therefore, 1 over gx will be the reciprocal of this expression. And clearly, it is not the same as what we got for 1 over fx. Therefore, they are not the same. Next, for b, we are given an existing graph and we are asked to first plot the internal mod x graph. So for this, we can omit the negative x segment of the original graph and then mirror the positive x segment of the original graph. And so we will get this graph. Next, for part 2, we are asked to plot the 1 over hx graph. So what I'm going to do here is I'm going to draw out the original graph. And I'll attempt my explanation by overlaying my new graph upon this graph. So first, all the x-intercept will turn into asymptote. So all this becomes vertical asymptote. Then I'm going to draw my invariant line, which is y equals to 1 and y equals to minus 1. These are lines which doesn't move during the transformation. So for this, it is more like a guiding line for us to quickly perform our transformation later on. So all these points will not move. So under this inverse transformation, big will become small and small will become big. So clearly, it looks like a mini reflection about the invariant line. Same for the negative y segment. The small will become big, big will become small, small will become big. And lastly, for here, you should cut through the invariant point and small become big, big become small. So with the concept of the invariant line, it actually makes our solution faster and easier to achieve. Finally, come to the last part, part 3, whereby we are asked to draw the gradient graph. So as per what I taught in class, I'm going to draw the original graph on top of it. And I will put the gradient graph below. The first step is to break the original graph into different parts according to the stationary points and asymptotes. So since there's only one turning point, we will break into two parts. For the first part, first we inspect the sign of the gradient. In this case it's downward sloping, so it's negative. Then we see how the gradient is changing. It's changing from some negative gradient value, negative k, to 0. For the second part, the gradient is upward sloping, so it's positive. And it's changing from some 0 to some k positive value. So with that, we can draw our gradient graph. So the first segment, it must be on the negative side and going from some negative k value to 0. From the positive side, you go from 0 to some positive k value. And that's it for part 3. And that's it for our tutorial. Thank you.